Hello everyone! If you're tired of measuring screws, bolts and nuts just to store them and reuse them after a project, this video will show you how to create a 3D printable screw sorter that lets you instantly identify diameter and length, with an additional option depending on whether you have a multicolor printer or not. To do this, we will use SOLIDWORKS xDesign, a browser-based CAD software that requires no installation. Here I click on Create to start a new project and I am ready to design. At this point I do not even need to decide whether to start with a part or an assembly, because in xDesign it is the same object. What I don't know yet is the size of my part, so I open an M10 by 70mm bolt to get a rough idea. I will use this part to size my first block. I move it using these simple handles, translations and rotations, and then start my first sketch. Now that I have a rough idea of the required dimensions, I draw a rectangle around the bolt. If I need to increase the size later, I can change the dimensions at any time. The same logic applies to the block depth, which I set to 10mm. Next, I want to create a groove to center the bolt. For that, I create a V-shaped sketch, and as you can see, I leverage relations to define it. This dimension appears in gray, which means it is not required. Once I add the 10mm dimension to the border, the sketch becomes fully defined and turns black. I then add a cut feature with a through-all end condition. This ensures that even if I change the part size in the future, the cut will always go through. This is called design intent, and xDesign helps enforce it at every step of the design. Now I want to add another cut so the bolt head is fully contained while measuring. This will also define the starting point of the measurement. This cut is a half hexagon, and once again I use relations to minimize the number of dimensions. With just one angle and one width, everything becomes fully defined, making future changes much easier. I then use the sketch to cut the part. I quickly check the head size using my M10 bolt, and I continue designing. Now comes the big part, graduations. For this, I need several rectangles positioned at precise locations. I decide to place tins on the right and numbers ending in 5 on the left, except for the first one at 6mm, which is more common in practice. I start with 3 rectangles for 6, 10 and 15, and I will pattern the 10 and 15 every 10mm. Once again, I rely heavily on relations, equal, align and coincident, to simplify dimensioning. I simply select 2 entities and choose from the relations proposed by xDesign. If the proposed relations look strange, it usually means I made a selection mistake. That part is very straightforward. Now I create the pattern, I select a rectangle, drag the handle in the correct direction, and define the number of instances. Here I also choose to add dimensions to the patterned entities, so everything remains fully defined. Once the dimensions are sorted, please don't judge me, I repeat the same process on the other side. I finish with an align relation for all middle edges and my sketch is now complete. I use this sketch to split the faces into smaller ones, which will allow me to remove material and create the graduations. To do this, I window select all rectangles and then remove the selections I don't need. With so many small rectangles, this is clearly the fastest method. I then remove material by 0.5mm, making sure the direction is correct. Now it looks good and I can move on to the numbers. This part is very easy. I simply use the text feature and define an anchor point. It only takes time because I want to add all the numbers. For the other side, I just change the text direction so the anchor point is on the right and I repeat the exact same process with the corresponding numbers. I then extrude the numbers, not too much though. 0.6 mm is more than enough. Next I move to the left side of the part, where I will measure nuts. For this I create hexagonal shapes. If you have watched my other videos, you already know that we need some additional clearance, 0.2 mm, to avoid nut jamming. Feel free to check those videos if you haven't already. Using my mechanical handbook, I add 0.2 mm to standard nut sizes and create a cut that is half the depth of the part, so 5 mm. I then show the previous sketch to reuse the hexagons and create circular holes to measure bolt diameters. Of course, I also add clearance here, 0.1 mm for small diameters and 0.2 mm for the larger ones. I finish with the through-hole cut. Now I need to add text to identify the nut sizes. I follow the same method as before and add sketch text. I also add a small line to clearly indicate which text corresponds to which hole. This avoids any confusion. To do this, I use the hole edge and apply xDesign's smart trimming tool to remove the excess. If I don't do this, I won't be able to insert the nuts into the holes, and that would be bad. Once again, I extrude the text by 0.6 mm and it's done. I would now like to add a magnet to keep the bolts in place, so I measure one that I already have. I create a small hole with some extra clearance and center it along this line. This way, any bolt, even small ones, will stay in place during measurement. After adding the hole and a small chamfer, I apply additional chamfers to improve the overall look of the part. Notice how I can use the xDesign Edge Assistant to select all corners with a single click. If I'm not satisfied with the preview, I can always select edges manually. Both methods work perfectly. The part is now finished and I can move on to the second phase, 3D printing. xDesign includes a dedicated feature for this, where I can choose the orientation and verify that the part fits within my printer's build volume. It then generates the correct STL file, ready to be opened in my slicer, the 3D printer software. In my case, I choose a height where the color will change automatically. Later, I will show how to achieve the same result with a single color 3D printer. Once sliced, I simply send the job to the printer. Now this is printing time. If you don't have access to a multicolor 3D printer, you can still add a pause in the printing program to change filament just for the text, as shown on screen. You simply choose the layer where the print stops, and the machine will pause so you can switch filament and resume printing. You can also print everything in one color and paint the text afterward. Here I used a white marker, but model paint works probably better. Once the ink smudge has been removed, I recommend sealing everything with a coat of varnish. I can now install the magnet, and as you can see, it fits perfectly. The bolt stays in place, no glue required, which I personally prefer. Now I can measure this M10 by 60 bolt in seconds, sort this M6 nut, and this M3 by 20 bolt, just as easily. If you want to design the same part today, you can go to solidworks.com/makers and start designing for a very affordable price. You will also find many tutorials to help you design the parts you want. Thanks for watching and see you in the next episode.